In this problem, we're taking a warm piece of copper, dropping that down into a container full of water. Because we have a small amount of water, we also need to consider the container that it's in, this aluminum can. And so in the end, the copper, the water, the aluminum are all going to reach the same final temperature. And we want to know, what is that final temperature? And so the final temperature is going to be equivalent to our first object's mass times its specific heat times its original temperature, plus our second object's mass times its specific heat times its original temperature, plus in this case now a third object's mass, specific heat, and original temperature. And then we're going to divide that by those same values but without the initial temperature. So the first object's mass and specific heat plus the second object's mass and specific heat plus the third object's mass and specific heat. And so whichever order we put these in doesn't make any difference. I'm going to do them the way I have them here. I'm going to say copper is my first object, the water is number 2, the aluminum is number 3. You could put them in the order they're written here, doesn't matter in the end. All right, so this final temperature, the mass of our copper, okay, notice everything is in kilograms. Our specific heats are also measured in kilograms, so we don't need to convert. So we have 0.15 kilograms of copper times its specific heat of 390 joules per kilogram degrees Celsius times it's going to start off at 60 degrees Celsius. Write a little clearer here, 60 degrees Celsius, plus mass number 2, so our water, 0.37 kilograms of water times its specific heat, 4186 joules per kilogram degrees Celsius, times its original temperature, 19 degrees Celsius, plus, run out of space here, plus our third and final object, the aluminum, 0.43 kilograms. I'm going to leave the units off here just so I can fit it on my page, times 900 times its original temperature of 19. And we're going to divide by those same values except for the temperature. We don't have the temperature, so 0.15 times 390 plus 0.37 times 4186. I'm leaving the units off here as well, and I'll show you why in just a second. Times, or plus 0.43 times 900. And the reason all these units, all these kilograms are canceling out here when we divide. These joules per kilogram degrees Celsius, those are all canceling out as well. So in the end, what we're left with is degrees Celsius, and we're adding all those together here in the numerator. All right, so 0.15 times 390 times 60 plus 0.30, not negative, plus 0.37 times 4186 times 19 plus 0.43 times 900 times 19. All right, so I had the value for that numerator. I want to divide that by the denominator, so 0.15 times 390 plus 0.37 times 4186 plus 0.43 times 900. And so we get a final temperature of 20.2 degrees Celsius. So that water and that aluminum, they do not change temperature very much because the water's high specific heat. The water heats up just a little bit, the copper cools down by nearly 40 degrees.